You're about to take a bite of your lunch, and right as you raise your fork, a housefly lands squarely on your meal. Flies routinely feed on solid, decaying matter, yet they completely lack the mandibles or teeth required to bite into or chew their food. Instead, they rely on the proboscis, a fleshy, tube-like mouthpart strictly designed for vacuuming up liquids. Because the fly cannot adapt its anatomy to chew solid food, it is forced to adopt the physical state of the food to match its anatomy. To bridge this gap, the fly employs extraoral digestion, vomiting highly acidic digestive enzymes directly onto the surface of the food. These enzymes trigger a rapid chemical reaction, liquefying complex solid matter into a consumable, nutrient-rich fluid soup. However, this process carries a dangerous secondary consequence. As the fly steps on and vomits on the food, it deposits a payload of pathogens, like Salmonella and E. coli, collected from previous visits to decaying waste. The most crucial phase of the fly's digestion happens entirely outside its own body. This effectively turns the human plate into a toxic external stomach. Inside, the alimentary canal is a single, continuous tube divided into distinct functional zones. The liquefied meal is pushed down the esophagus into the foregut. Food can then be diverted into the crop, an expandable sac that temporarily stores the meal for survival. From the crop, the meal moves into the proventriculus, or gizzard. This organ is often lined with microscopic cuticular teeth, which mechanically shred any remaining tough or fibrous materials that the external enzymes didn't fully liquefy. The foregut acts as a physical staging ground, ensuring the meal is stored and shredded before chemical extraction begins. Past a controlling valve, the food enters the midgut, the major site of digestion and nutrient absorption. Unlike the foregut, the midgut lacks a hard cuticular lining. This leaves the delicate internal cells exposed to abrasion and the pathogens in its food. To protect itself, the fly's midgut cells continuously secrete a protective structure called the peritrophic membrane. This fibrous sleeve is a selective shield, wrapping the food bolus and physically separating the toxic meal from the delicate gut walls. Its permeability is precisely tuned. Digestive enzymes pass inward to break down food, while safe nutrients pass outward into the fly's blood. The peritrophic membrane allows the fly to extract energy from decaying matter without being poisoned. At the junction between the midgut and the hindgut, the processing line meets the Malpighian tubules. These tubules permeate the body cavity, acting like kidneys to filter nitrogenous waste and toxins directly from the fly's blood. The remaining waste material and digested matter then move into the final stages of the hindgut. Here, the fly initiates a final process, reabsorbing water and vital salts back into its body. This conservation of fluid prevents the fly from being weighed down by excess water, ensuring it remains light enough for flight. What began as solid decay has now been systematically dismantled into base cellular components. These purified nutrients are deposited into the fat body, a storage network providing the energy required for survival and reproduction. The shape of this pipeline adapts to the species' diet. It can be short and wide for plant-based food, or long and convoluted to maximize the surface area for a liquid-only diet. The housefly operates as a biological machine specialized for converting decaying resources into immediate cellular energy. Because of its high-energy lifespan, this digestive cycle is constant and unending. This system allows flies to act as nature's cleanup crew by accelerating decomposition, even as their feeding method spreads human disease. The next time a fly touches a meal, it has initiated a specialized disassembly line, an interaction that usually ends with that food being thrown in the trash.